Hi everyone. My name is Mark Bostley. I am the product manager for PingAccess, which is Ping's access control web access management product. Welcome to our session. This is our Masterclass, a deep dive into our AWS automation story that we released last spring. So I'm just going to dive straight into a couple little, level setting slides about, what we're talking about today. And then I'm going to turn it over to Dan McNulty, who's our principal developer, principal technical engineer. And he's going to get into the kind of the guts of the way that this solution works. We're going to be looking at code today. We're going to be looking at scripts today. And he's going to be talking you through a whole bunch of stuff. So, strap in. All right. So, as a web access management product, that focuses on access control and policy enforcement, it makes really good sense in today's hybrid environments and in today's migration and environment where people are moving applications from data centers out to one or more clouds, that the thing that is applying the access control, the thing that is enforcing session management, whatnot, can go along with those applications out to where they're being deployed instead of remaining within kind of your walled garden the way a legacy web access management product would work. Now, PingAccess is a little bit unique from some of the other ones because it does rely on a federated relationship between itself and the authentication authority. So your authentication authority can actually stay local in your data center next to where your user records are. Now, obviously, as those user records are moved out to other places, that authentication authority needs to migrate with them, but the applications should remain independent of those. So when we kind of tackled this, we looked into, what is it that we really want to accomplish with automating the deployment out to the virtual private cloud. Now, we chose to focus on Amazon. I'm going to talk about that here in just a little bit. But we really kind of narrowed in on a number of different kind of business functions that our customers are looking for that go well beyond just providing like a VM or a Docker image that, it's a chunkable, kind of deployable object, but it doesn't bring all of the orchestration and all of the other pieces with it. And so automated deployment is kind of the bedrock of all of this, being able to, deploy things to AWS in a, codified, automated way. But we also wanted to enable more advanced use cases like elastic scaling using CloudWatch. We wanted to enable zero downtime upgrades and environment migration so that you can really take advantage of those kind of immutable server principles that AWS allows you to take advantage of in their environment. So now, why AWS? Well, AWS provides a ton of different services, native and available to anybody who's an AWS customer. And we were able to leverage these services so that we can implement this solution, or we can provide these templates that implement these solutions without requiring you to go out and license and buy and learn a bunch of third-party software that we prescribe and say, hey, you're going to have to learn how to use this other thing, even though you might not have any experience with it in the past if you want to take advantage of this service. And so, there's a number of different core services that we leverage. They're kind of highlighted in red and outlined on the left-hand side of the slide. Don't worry, there's not going to be a test on this part later. I'm moving pretty quick because I want you to turn you over to Dan here as quick as possible so he can really get into the guts, the stuff that you guys are really here to see. But that's kind of the environment that we use within Amazon, the services that we're using. Now, what does Ping provide? Well, we're providing a bunch of different CloudFormation templates written in YAML. These CloudFormation templates do a number of things. They're kind of elaborated here on the left-hand side of the slide. And they're setting up things. They're running the automation, but they're also deploying things like LAMBDA template or LAMBDA code that does API calls into our administrative instance to be able to provision things. Or it sets up all of the load balancing. It sets up all of the virtual private cloud. It sets up SSH bastion hosts, those types of things. I talked about the LAMBDA and what it does a little bit. I'm sure Dan will get into more of the details about that here in a little while. But we also are providing some CloudWatch rules that use utilization metrics that come out of PingAccess as well as out of AWS's monitoring systems to be able to instruct EC2 when to scale up or scale down a particular runtime cluster. So with that, I'm going to go ahead and turn it over to Dan and take it away. And if anybody has any questions, raise your hand.
Thanks, Mark. So now I'm going to dig into more detail. What is Ping providing? So we can really split it up into two categories of things. There's AWS specific things, and then some Ping product config as well. So the first set of stuff you'll see on the AWS side is the CloudFormation templates. And so CloudFormation is Amazon's infrastructure as a code service. And it allows you to basically write a template which defines the properties of the resources that you want to provision. It'll take the template in and provision them into a group it calls a stack. And typically one template will translate to one stack. Ping is also providing the Lambda source code. And this stuff will, the Lambdas will do various things. They'll configure the resources provisioned by CloudFormation. Then they're going to do some automated deployment maintenance, and then they're also going to integrate with CloudFormation to implement this custom resources use case. And this is really an extension point in CloudFormation that allows you to do some pretty advanced stuff. So now I'm going to give you a crash course in CloudFormation, which is really the foundation of the Ping provided automation. And so I'm going to kind of step through snippets from a single template that's going to provision a virtual private cloud. So the first section you'll see in a CloudFormation template is the parameters. And so the purpose of the parameters is to allow a user of a template to customize the creation of the resources without having to change the template. And so we can see here two parameters listed. First one, VPC name, that's pretty straightforward. And then there's this export name prefix. This is a bit more complicated, but it's a convention used throughout the Ping automation to allow you to take the same set of resources and deploy, create multiple deployments. So it's really used to segment those resources after they're created. And I'll get into this aspect of it a bit more in a few slides. So example of what you typically might see in terms of using these parameters to customize your deployment is in defining the Amazon machine image or AMI IDs. So within Amazon, these IDs are actually region specific. So the templates provided by Ping, they use defaults from US West 2. So if you want to take these templates and deploy in another region, you're going to have to go and change these. And so Ping provides access to do this. You don't have to change templates to deploy in another region. And this is just one example of what you can customize in terms of the parameters with the Ping templates. The next section you'll see in a CloudFormation template is the resources. And really this is defining what you're actually provisioning. As you can see, here's a snippet to define a virtual private cloud. A few things to note, you can refer to parameters and you use this !ref construction to do that. And if you look at the last line here, you'll see that we're referring to the VPC name parameter to define the name of the VPC that's being created. So CloudFormation will take those resource definitions in and create the resource in the Amazon service. And the result of that will be Amazon probably assigning an ID to that resource. That's really useful. You're going to want to use that in other places. In particular, CloudFormation allows you to segment your resources into multiple templates. Allows you to create a modular structure, which makes it easier to manage. But in order to allow multiple templates to refer to resources created by each other, CloudFormation supports this idea of an output. And basically what you're going to do is you're going to refer to a resource defined in the template, and that's going to be specified in this value field. You're also going to export that value, which basically tells CloudFormation, hey, take this ID and make it available for other templates to use. And this is where we see that export name prefix coming into play again. So within CloudFormation, the export namespace is actually global to a region. And so every export name needs to be unique. So the way we deal with that within the Ping templates, but still allow you to use the same set of templates for multiple deployments, is to use this export name prefix. So I'm going to jump over to the Amazon console to take a look at this in action. So I've already went through and done the deployment, and as part of it, it set up this export for an VPC. And so that's what we're looking at here in the Amazon console, is just you can look at all your exports, and you can see that the value of the ID here for the VPC that was created. So when you define an export, you're going to want to use that in another template. And the way you're going to do that is with an import. It's going to follow a similar pattern in terms of defining the export, but you're going to use this import value statement here on this last line, and it's going to use the export name prefix to kind of, as a parameter to link back to the ID that was defined by an export. So that's a crash course in CloudFormation. So I also mentioned that Ping provides the Lambda source code, and now I'll get into the details of that. Ping provides the source code as a zip file, and this is because this is the format expected by the Amazon APIs when you're creating a Lambda, so it's really easy to just take the source code, push it, and create a Lambda. But within that zip file, you actually have the source. So within that, you're going to have an index.js file that's going to contain the JavaScript source code for the Lambda, and then you're also going to have this node modules directory. This contains any third-party open source dependencies that the Lambda is using, as well as maybe some libraries that you write yourself. So let's take a look at this index.js file and see kind of the anatomy of that. There's a lot going on here, but this is really just a stub, and I'll step through kind of some key takeaways from it. The first line here, this is defining the function signature, the entry point into the processing of the Lambda. And really the takeaway is the Lambda is going to take in an event, some sort of context related to that event, and then a callback. That basically will signal to the Lambda service that the processing of the event is complete. The next line here is actually interesting as well because Lambda integrates with CloudWatch logs. So as your Lambdas are processing events, any logging you do is automatically routed to CloudWatch, which makes debugging a lot easier. The last takeaway here is that you can complete a Lambda successfully and also with an error, and those result values get passed up to Lambda, and then there's some monitoring around that to see, when did the Lambda succeed and when did it fail. So that's what Ping provides from the AWS aspect of the automation. The automation source also includes some Ping product config. So within that, you're going to see some PingAccess configuration defaults that are tailored to AWS. And within that, you're going to see some changes to logging. On every EC2 instance created by the deployment automation, we're going to have a CloudWatch logs agent running. And this will take all the Ping logs and push them up to CloudWatch logs to give you a nice aggregation point for all the logging data created by the software. Then there's going to be some configuration to allow authentication to the admin UI and API within PingAccess, leveraging PingFederate as a authentication authority. And I'll dig into that in further detail in a bit. There's also going to be some changes to how the PingAccess engines expose monitoring metrics for the purposes of informing auto-scaling decisions. I'll also dig into that in a few slides. We also provide a PingFederate plugin that really kind of gets into this authenticating to the admin UI and API use case, where you'll be able to issue, PingFed will issue an OAuth token given IAM credentials. And then this last piece here is we give deployment automation for creating an internal certificate authority using HashiCorp's Vault product. Now in the interest of time here, I'm not going to dig into the details of this and focus on the Ping specific stuff. So you might be thinking, great, that all looks awesome. What can I customize? Well, the short answer is everything. You have all the automation source, and it's provided as a reference deployment. So the idea is that what we give you is what we, Ping, think is a good way to run PingAccess in AWS. But certainly your requirements might differ from what we decided was our reference deployment, so you're encouraged to modify and extend what we give and use that to meet your requirements. So along those lines, what do you provide? What do you bring to the table to use this deployment automation? Well, you're going to define what PingAccess distribution you're going to use. You're going to bring along a PingAccess license. You're going to bring along the Oracle Java runtime environment downloaded directly from Oracle. You might have some existing AWS infrastructure that you'd like to integrate with. This is an optional piece, but it's certainly an expected use case. And then any customizations to the automation that you'd like to make to meet your requirements. All right, so combining that all together, let's walk through a high level of what the deployment is doing. So you're going to modify the automation source to meet your requirements. You're going to copy the PingAccess distribution, your license, your JRE, alongside the automation source. Then you're going to use CloudFormation to create an S3 bucket, which I will refer to as the automation repository. That'll contain the automation source. Once that bucket's created, you're going to upload the source to that bucket, and then you're going to use CloudFormation to provision the resources. And CloudFormation at this step is going to pull templates from this S3 bucket. Once resources are created, they're going to actually reach out to this S3 bucket as well and pull down config. It kind of becomes the central point of the deployment. So before this talk, I went through and used the ping automation to go through a deployment. And now I'm going to kind of step through some interesting aspects of that and dig into it in more detail. So first, set the stage for what I decided to do. So I assumed that I had an on-premise private data center, and it's represented here in this box. Within that, I have a privately resolvable DNS host domain called onpremise.private. Within that data center, I have a production PingFederate deployment, and I'm using it internally for my internal applications. But I want to go to AWS. I want to leverage the public cloud. So really the first thing I'm probably going to work on is defining a virtual private cloud. In addition to that, defining the virtual private cloud and all the network details around that, I'm going to create a private hosted zone, which is just a privately resolvable DNS domain. And here I'm going to call that ping.private. The whole point of going to Amazon is to deploy your applications there, so I'm going to do that. That might involve many things. You're going to deploy some EC2 instances, some load balancers, anything. Then you're going to want to bridge the gap between those two, the on-premise data center and the virtual private cloud. You're going to set up a VPN to do that. Lastly, you want to serve your applications over the public internet. And part of that is provisioning a publicly resolvable domain name. And here, for this demo, I used ping-demo.com. So let's dig into what you need to do for this VPC that you are creating outside of the deployment automation so to make it compatible with what Ping expects to be there. So you're going to need public subnets. And this is nomenclature that comes from Amazon. But the basic idea is that resources deployed in these subnets are meant to be internet facing. And so for the ping automation, we actually use this for the elastic load balancers. Then you're going to have private subnets. These don't have public IPs, and this is where we're going to put all the EC2 instances. Then you're going to have this Route 53 private hosted zone. This is that ping.private domain I referenced on the previous slide. And then you're going to have some security groups that really enable administrative access. Every EC2 instance provisioned will be associated with a group to provide SSH access. And then there's a group that is going to grant access based on IP to the PingAccess admin node. So now I'm going to switch back over to the CloudFormation console here and look through the examples of using one of the stacks. So previously, I went through and set up a VPC, and then what the goal of what I'm doing here is I need to tell the automation about it in a standard way. And so I'm going to spin up a template, and it's going to prompt me for a bunch of IDs for these resources that already exist. I'm going to put those IDs in, and basically tells the ping automation all about the existing infrastructure. Then I'm going to run it, and what it's going to do is it's going to generate a bunch of exports. And this is how the ping automation, you don't have to change the templates to make this work, but you're going to basically take some IDs and make them available under some standard name. And you can see that over on the right here. I referenced this DMIDV VPC. That's an export that defines the VPC ID to use for all the deployment automation. So I mentioned this automation repository and it kind of being the central point for the deployment automation. And now I'm going to go into detail what ends up here after deployment and also what's there to begin with. So all the automation that runs, they're going to produce some configuration artifacts. Those get pushed to this S3 bucket for the sake of persistence. And those are going to end up in this automation artifacts directory. The next directory here is this instant init util. This is just some scripts used by EC2 initialization. The internal CA, that's configuration and scripts to provision an internal CA. That's I mentioned that earlier. And then the JRE directory is going to contain the JRE distribution you're bringing along. And then the PingAccess directory, that's going to contain configuration, LAMBDA source, the CloudFormation templates, all of the stuff related to deploying the PingAccess cluster. And then any customization you're going to do is actually going to end up there. So let's dig into what was produced by the automation, what got pushed to this bucket. And so here we see this export name prefix again. And so it is similar to the CloudFormation case. We want to be able to use the same S3 bucket for multiple deployments. And the way we segment the configuration files produced by a particular deployment is to put them under this export name prefix. So we dig into that directory further. We see a CA directory. This is related to that internal certificate authority. And then a PingAccess directory, which will contain some admin and engine config. Dig into that directory further, we see that there's a conf directory. This contains encrypted admin config and some logging configuration. And then this engines directory. So this is really about the orchestration between the admin node and the engines. So when an engine is spun up, there's a Lambda function that gets called. It'll talk to the admin, register the engine, get this bootstrap file. It then turns around and places that bootstrap file in this S3 bucket at this location using another subdirectory within the engines directory using a conventional name. And so when the engine spins up, it knows, okay, I'm going to go look at the S3 bucket in a particular spot to pull down my engine bootstrap config. It then reads that, and then it knows exactly how to talk to the admin and authenticate to it. And then this last directory here, this is just some jars that are doing integration with AWS. So I talked about the artifacts that are produced by the automation. Now let's talk about the resources actually created. So we have EC2 instances. There's going to be 3 types of those. There's the PingAccess admin node. There'll be one of those at any one point in time. There'll be the PingAccess engine nodes. There'll be any number of those depending on the load. And then there's this internal certificate authority instance. For each of those, there's an auto-scaling group, which is really about maintaining availability of those instances. That's particularly important for the engines because those are actually going to do the elastic scaling aspect of this. And then in addition to the auto-scaling groups, we have the elastic load balancers. There'll be 2 per PingAccess type of node. One's going to be internet-facing, and the other one's going to be internal. So recall this is where we were working with. What the goal was to take this existing infrastructure and deploy PingAccess into it. And so I'm going to walk through how that shows up in this diagram here. And the resources created by the deployment will show up in this yellow box. First one to look at is this PingAccess admin node. And so what's going to get created is an EC2 instance, a few load balancers, which there's only one shown here for the sake of simplicity. And then there's also an auto-scaling group. So let's now dig into a few details related to the admin and what's interesting about it. So you might notice that the admin, there's only one. But you might think that's a single point of failure. So the way we kind of work around that is to leverage an auto-scaling group to monitor the admin node. So in this scenario, we have PingAccess engines. They're reaching out to the admin to get config. They're going to go through an application load balancer, and that in turn is going to route to the admin. Let's say for some reason that the auto-scaling group that's monitoring the admin decides that instance is no longer available. So what's going to happen in this case is that the ASG is like, well, I need to replace that node. So in this scenario, the admin node is no longer running, but that's okay. The engines actually continue to process traffic. The only service you really lose is the ability to make a configuration change. So the ASG is hard at work spinning up a new admin node. When that admin node gets to a certain point, it's going to reach out to this S3 bucket and pull down the config. Now, this process should probably only take a few minutes. And in that point of time, you don't have access to the admin API. So this is the process we used to kind of maintain some availability in this scenario. So here's an example of this configuration file that I just mentioned that the admin's going to pull down. It lives in that S3 bucket, and it's just a JSON payload. If you're familiar with the admin APIs, this is actually just an export, and any sort of sensitive information is actually encrypted. Okay, so I mentioned earlier that we're going to leverage PingFederate to authenticate access to the admin APIs. And I mentioned also that we have lambdas talking to the admin API. So if you're familiar with Lambda and how it works, you can associate an IAM role with Lambda. And so the way that PingFederate comes in is that we're going to bridge the gap between an IAM role and OAuth. We're going to leverage PingFederate to do that bridging. So now I'm going to dig into that in a bit more detail. So here's the scenario. We have PingAccess and we have a Lambda. The Lambda wants to get access to the admin API, but then but it's going to need to get an OAuth token first. So to do that, it's going to take its IAM credentials that the Lambda service exposes to the Lambda. It's going to include those in an OAuth authorization request to PF. PF is then going to take that and validate those credentials via an IAM API. And that process is also going to pull down the permissions for that IAM role. Once it has that, it's going to package all of that metadata up into an identity, and then PingFederate is going to issue an OAuth token for that identity. Then, once it has this OAuth token, the Lambda is going to use it to gain access to the PingAccess admin API. Upon receiving this OAuth token, PingAccess is going to validate it and inspect it. And what it's actually looking for is a specific permission that was associated with that IAM role. And that's how it's going to decide whether or not to grant access to the Lambda. So you might be wondering, okay, that's great. How do I tell PingAccess about my existing PingFederate and leverage that for this use case? Well, it's actually pretty simple. There's a config file you're going to update and modify when you upload the automation source to this bucket. And really, it boils down to what's the host and what's the port of the PingFederate installation. So I just covered one interesting aspect of deploying this PingAccess admin into this existing infrastructure. Now let's look at the engines. So we can see here, adding to the diagram, we have any number of engines. They're going to have routes to the PingAccess admin node, to the VPN that'll provide access to PF for any back-channel calls. It's also going to have access to your applications, right? It's going to sit in front of them. Then there's going to be this public-facing load balancer that's going to be the ingress point for any internet traffic. That's going to get routed to your engines, and then it's going to route that to your applications. That's how you're going to expose your applications over the internet. So now I'm going to dig into the auto-scaling aspect of the engines. And so I mentioned earlier that as part of the Ping automation, we provide some customization to the health metrics that are exposed by individual engines. So here we have a JSON document that's now exposed on each PingAccess engine at this URL here, this heartbeat endpoint. And so let's look at the details here of what's being returned. So the first section here is the CPU. This will be the number of logical processors on the EC2 instance, as well as the load average. And then there's some PingAccess specific processing statistics. So the first thing is this processing time in milliseconds. This is the amount of overhead that PingAccess is adding to transactions it's processing. Then there's this concurrency metric. This is the number of requests being processed by PingAccess. And then these last two values are actually 90th percentile measures. And so the response count here is how many samples were used to compute those. So every minute, a Lambda is going to run, and it's going to actually hit the endpoint of all the engines, gather that data all up, and then run some math on it to compute this cluster load metric. And what this metric is a weighted average of all that metric data we just saw. So here's a simplified formula of what's being done. So the CPU, that's going to be about 50% of this weighted average. The PingAccess processing time, that's going to be about 20%. And then the concurrency is going to be 30. What the resulting value is this load metric, and should range between 0 and 100. It actually can get above 100 when the capacity of the cluster is it's over capacity. And so we're actually going to define a CloudWatch alarm that's going to monitor this load metric. And what the alarm's going to do is says, if the cluster load is greater than or equal to 75% for 3 minutes, sampling every minute, fire. So the way that CloudWatch alarms work is that they're hooked up to some sort of event sync. And in this case, we're going to hook it up to the auto-scaling group. And when this alarm fires, it's going to tell the auto-scaling group, you need to add more engines. So now, I'm going to jump back over to the AWS console and walk through an auto-scaling event. Before this talk, I ran a load to simulate an auto-scaling event. And now I'm just going to walk through some of the details. So what we're looking at now is the configuration page for that CloudWatch alarm. And we can see here that at 14:26, the alarm fired. And then as a result, it generated an event that got routed to an auto-scaling group. So then if we jump over to the auto-scaling group, we can see, okay, 1426, a new engine got spun up. And so we started with 2, we now have 3. Now you can see here that the auto-scaling group is reporting I spun up another instance at 1438. So what happened here is that the load persisted, ran for 30 minutes. But so after adding the first engine, that wasn't enough to bring the cluster load down below the threshold of 75%. But so the reason that didn't happen sooner to add this extra engine to deal with this extra load is that auto-scaling groups have this notion of a cooling down period. And so the default configuration is to have that to be 10 minutes. And so basically that tells the auto-scaling group, hey, don't add any more engines until 10 minutes has expired. So now within CloudWatch itself, you can look at this metric over time. And so this is the window here is the period of time in which I ran the load. It ran from 1422 to 1452. And so we can see right away when I started the load, the cluster load was at 120, right? That triggers the alarm after 3 minutes, right? And so we saw that the auto-scaling group added a node at 1426. Takes a few minutes for the engine to start up, but then we see the load start coming down, right? A few minutes later, at 10 minutes later, we see that the load is still above the threshold. So auto-scaling group's like, okay, I still need to keep adding engines. So eventually, we see it drop below that threshold, and then it's going to stop any engines. And then then we see kind of the cluster load level off here until until I stopped running the simulation. So that's just an overview of what you can do from a dynamic auto-scaling perspective, but you might be wondering, that's too complicated for my deployment. My workloads are pretty predictable. I want to do something simpler. Well, you can actually do scheduled scaling. The templates don't support it out of the box, but it's actually pretty straightforward to do. So the first thing you're going to do is you're going to remove this auto-scaling strategy template. Basically defines all that dynamic stuff that I just talked through. You're going to remove it from the deployment, so it's not even referenced. And then you're going to enhance this engine auto-scaling group template to define a scheduled action. And you can think of scheduled action as a cron job. 8:30 in the morning on Monday, I'm going to add some more engine nodes to the cluster. And then, when the business day is over, I'm going to scale that back in. So this all is great, but what do you do when it goes wrong? One nice integration point is with CloudWatch logs. I'm just going to give you a brief view of that right now. So what I'm looking at now, this is the engine audit log from a PingAccess engine node. And I said earlier that every EC2 instance that gets deployed is integrated with CloudWatch logs. We then tell CloudWatch logs to look for PingAccess specific log files and have them routed to the service. Right? So then what you see is that you have all your logs there to query. It's a pretty simple interface, but it's nice. It's integrated as an Amazon service. You don't have to go to talk to a third party to get this done. So that's why we kind of went with this approach. It's pretty simple, but it could get the job done. So that's the PingAccess deployment. We added the engine admin nodes and some load balancers, and then we added the engine nodes with some more load balancers. That's just the basics of getting started. And so now we have some extra time here. I'd like to take any questions you have about the deployment.
Where did you specify the Java binaries, the PingFed binaries, to say copy those onto the Linux system?
Right. So those are specified in the CloudFormation template that defines the resource for the EC2 instance for each particular type of node. And so there's an aspect of that where you point it at the S3 bucket and say, okay, here's your binaries, copy them down, unpack them, right? Doing basically the instance initialization.
And I'll come around with a microphone so that we can get the question.
Do you have the templates available, and do you have the templates for putting PingFederate in AWS?
So the templates are available. You just come talk to Ping. And we actually, with PingAccess, we provide a demo instance of PingFed. but we don't have the production PingFed templates ready yet.
Is that on the roadmap?
I'm gonna let Mark answer that one.
Yeah, so we actually do have a plan to be able to build out a full automation story for all of our software. We have people dedicated to working that out right now. We're looking at a number of different things, not only expanding beyond PingAccess to other software within our portfolio, but also expanding beyond AWS to other providers, as well as even like your local data center.
Awesome. And then I know regions can't talk to each other, so if we wanted to set up an AWS environment in both US East, US West, and then potentially Europe, how do you do that with PingAccess if you have applications that are also distributed, that want to be distributed globally?
Right. I think CloudFormation has a feature called config sets. No, I'm sorry, that's not for that. You should be able to use, you need something external to orchestrate deployment in multiple regions, but I don't think there's anything stopping you from doing that.
Can you give an idea of when something like this would be available in Azure?
So we don't, sorry, the question was when is it going to be available in Azure? So Azure doesn't have the same construct of like CloudFormation and all the orchestration engines. So what we've done, we actually had some conversations with Microsoft this morning to try and align resources to start understanding a little bit better what the capabilities of the Azure IaaS deployment structure was, as well as what's available for us to use. I kind of showed you that slide at the beginning of all of the different services. I mean, we were only using probably 6 out of maybe 200 or 300 that are available. So we're kind of trying to figure that out. I mean, I know that there are orchestration engines out there that we could go in on, but as I answered him just a few minutes ago, we're still figuring out exactly what that story is going to be. So I can't give you a date yet.
Okay.
No, go ahead.
I got another question.
We got plenty of time.
The heartbeat that you're showing there is probably more, so we're using PingAccess 4.3 right now, and we're going with just the OK heartbeat.
Right.
Because we don't want to give that information externally. Is that a new capability in 5.1 to show the more details in there, and can you limit that to just internal queries?
Right. So it's actually, that's new in 5.0. And the way we actually set it up is that it's a velocity template, so you actually can do some processing. So what we've done with this deployment is we're looking for a specific header that's set by the AOB, and then if it's set, we expose the more detailed information. But if you were to hit the endpoint directly from the internet, say, you're going to get that OK heartbeat. So that's how we kind of lock that down.
This is just a quick one. How many AMIs have you tested it on? Just the standard AWS one, or is there multiple that this can be done with?
Right. We did it with out-of-the-box Amazon Linux, and then we've done Red Hat, the official one.
Yes, 7.3.
Yeah, I'd have to look it up.
Okay.
It's documented in the template what you can do.
So just to kind of build on that, the reason why we look at the Amazon Linux image is because part of the setup is to actually instantiate the operating system on the EC2 instance and to do the patching. And if you use the Red Hat distribution, it's not kept as current. And so the actual call out to go, what's the actual call to go get it? It's like a
Yum upgrade or something like that. Yeah.
It's a yum command, and so it takes time for that to happen. And whereas the Amazon Linux one is kept very current by them, and so that yum upgrade takes just a fraction of a second or a couple seconds. So really, it's more of just kind of that. But if you have your own AMI that you want to use, that's in an operating system that you guys already use within your organization, and you've decided is the kind of official one, you can reference that as well. Yeah. All right. Other questions? Oh, way in the back.
Does this work in GovCloud, or does it only work in commercial cloud?
We've only qualified it in the commercial cloud. I'm not aware of all the limitations on GovCloud, so it'd be tough to say if it would or not.
If you'd like to take a look at it with us, though, and provide us, some of the information and some of the experience you have with that, then we could take a look at that as well. All right. Oh, sorry.
Yeah. For day one, we wanted to just deploy the engine nodes in the AWS and
Right.
still point to the admin node in on-prem.
Right.
Where do you actually change that? Is it the YAML?
Right. So I was thinking about that one. You can take what we've done and kind of really customize it. So you can probably take the engine related templates and leverage that. There's going to be some, the engines expect to receive Bootstrap configuration from this S3 bucket. So you're going to have to change how that works because that's all orchestrated and defined and set up by the deployment automation. But it's certainly possible. It's just you're going to have to take what you've done, what we've done, and kind of really customize it for that use case.
But how difficult it is, like, after people change?
I'm sorry?
How difficult it is to change the script yourself?
How do you shell?
Yeah. How much time does it usually take?
Oh, time.
How hard is it to change the scripts, and how much time does it take?
I'd have to think about it more to give you an accurate estimate, but I don't know. It's good.
I think that the general answer is that the simple changes, the textual changes, changing some of the default settings and those types of things obviously just takes a couple seconds, right? If you need to change some of the processing of the way that these things are done, then it's going to be a deeper integration, and it's going to depend on how much of a change that actually is. But at the end of the day, these are intended to be ultimately flexible. And so with the right expertise, you can go in and make those changes. Okay, go ahead, Greg.
Yeah, from a customization standpoint, are there any concerns with trying to use AWS resources from other accounts? So, for example, using a certificate generated in a different AWS account, or using a Route 53 zone in a different account?
I don't think so. I think it would just be a matter of setting up the IAM permissions so that you can delegate access from one account to the other. If AWS supports it, it certainly should be possible to go in and make changes to do it.
All right, do we have more questions?
Cool.
Be shy. All right.
All right. Thank you.
So before everybody leaves, I have a favor to ask. We put a lot of effort into trying to put together the right level of content for these master classes to make sure that they're the right level of technical content as well as trying to understand the business. And it's hard to level set and provide that level of depth. So if you guys can go in, if you have the Identiverse app, and just fill out the quick survey and really kind of just give me some feedback on that so that we can take it back and continue to develop these master classes. I'd really appreciate that. All right, everyone. Thank you.